Hi there, hope you're doing well. This video today will talk about a couple of laws of exponents and radicals. Radicals, roots, and powers. We're just going to look at primarily two different laws of exponents. The first one is this way of translating between a radical expression and an exponential expression. So the nth root of x to the a power is the same thing as saying x to the a over n. It's just a way of translating between one form and another. The other rule that we'll look at today, you might call it the product rule for radicals. It's when you have the nth root of a product, like the nth root of x times y, you could rewrite that as the nth root of x times the nth root of y, as a product of radicals. So a radical of a product is the same thing as a product of radicals. Okay. A couple of things to point out here about this first law, and this is true for all laws of exponents really, that is we are saying that when that one expression on the left, the nth root of x to the a, equals x to the a over n, we are saying that they are the same thing. They are just two ways to write the same thing. It's sort of like saying if you drove your car to work one day or you drove your automobile to work one day, that really is saying the same thing. We're using a different word, car or automobile, but it's not that one is wrong and the other one's right. They're just two different ways to say the same thing. I could just as easily have written x to the a over n equals the nth root of x to the a. It's not that one's better or worse. They are the same. And your goal is fluency between one form and another. Incidentally, we could also write this as the nth root of x to the a power. All of those are the same. Now this last one that I just wrote there, that may seem a little surprising to some people, and I just wanted to dig a little bit into that because sometimes people see this and they get a little bit confused. But the reason that I can use that form there to say the same thing once again is because of the second rule, this product rule of radicals. So let's take a look at an example, and I'll show you why. If I have something like the cube root of x squared, all right, well, you know that x squared is the same thing as x times x. So that's the cube root of x times x. Well, there's a product. Look, I could rewrite that as the cube root of x times the cube root of x as a product of cube roots. Well, I'm multiplying something times itself. So I could also write that as the cube root of x squared. Okay, so that's why that second law allows us to kind of extend the first law into yet another form. Okay, so hopefully that makes sense. All right, it's time to look at a few examples here. Let's see, the first one, you know what, we'll just take a look at that same thing that we just wrote there, the cube root of x squared. I could write that as, yeah, you got it, x to the 2/3. Pretty simple. Just two different ways of writing the same thing. Which one's better? It doesn't matter. Well, it could be that the exponential form gives you some advantages over the radical form. I think a lot of people would say that. But it's not that one is better or worse or right or wrong. Let's look at another one. Here's the fifth root of x to the third times y to the fourth. I can take advantage of my product rule there and write that as the fifth root of x cubed times the fifth root of y to the fourth, and then I could write those as x to the 3/5 times y to the 4/5. They're all good. Just depends on what particular purpose you have in mind for these expressions. If they're part of a fraction and you want to cancel out some common factors on the top and the bottom, you know, one of these forms might be more useful than another. Okay, let's do another example, and this one will show you that, you know, these rules go either way. I can take fractional exponents and write them as a radical. So I've got a to the 3/4 times b to the 1/4, just times plain old c. All right, so the first two, a and b, they have those are roots. So I could write that as the fourth root of a cubed times b. All right, so you all right with that? Then the c is outside the radical, and so just for clarity, we normally would write things in front of the radicals, just so there's no confusion about whether that c is really supposed to be under the radical or not. All right, that's how we would probably write that expression right there. C times the fourth root of a cubed b. Let's take a look at another one, another type of simplifying things. Here's the cube root of three things. So let's just go straight to the exponential form there and write it as x to the 6/3, y to the 5/3, and z to the 1/3. Well, let's not forget there that 6 over 3 equals 2, and it's better, much better actually, to write that as x squared times 5 times y to the 5/3 times z to the 1/3. Okay, so just a few examples there of translating back and forth between radical form and exponential form. I think it's good to summarize here about these fractional exponents. They are always constructed as the power over the root. Okay, and you can check that with all these examples on this page right here, that they're all written that way. And you can remember that, I think, pretty easily by remembering that, you can think of the power coming from above, like lightning bolts or something like that, and then the roots going down into the ground. It's a good little way to remember what goes over what. All right, let's do some more examples here, and just a couple more, I guess. These ones will focus a little bit more on the radicals. So if I have the square root of 3x cubed times the square root of 18x to the 5th, those are both the same root there, square root, so I can put them into one radical, square root of 54x to the 8th. Well, I could leave it that way, but if I really was trying to simplify this thing down as much as possible, I would probably want to simplify that square root of 54 and the square root of x to the 8th. I can write those in a little bit different form, that is. All right, now I'm not saying that this is something that has to be done every single time, but it's a good habit to be in, and it's an excellent skill to be able to translate from one form to another. The most simplified form is usually the most preferred. So 3 root 6, that's the same thing as the square root of 54. Hopefully you remember how to simplify radicals like that. And of course, just like some of the other ones we've seen today, 8 over 2 equals 4, so x to the 8 over 2 would be better written as x to the 4th. And again, we put the numbers that are not in radicals in front of the radical and write it just like that. All right, 3 times x to the 4th times the square root of 6. Let's do another one, which if you took the quiz recently in my class, this one may seem a little bit familiar. It's not exactly the same, but it's pretty darn close. I've got a cube root times a square root times a cube root. Okay, notice that those roots are not the same, so I can't just combine them into one radical. All right, that rule of the product of radicals only works when all the radicals have the same root. But two of them do have the same root. So I could combine those, or I could just kind of go straight into the exponential form. I think you'll find that a little bit more advantageous. But don't forget, when you have the cube root of 2m squared, that cube root also applies to the 2. So that's 2 to the 1/3 times m to the 2/3. And then times m to the 4 over 2, but I think we'll just write that as m squared. 4 over 2 equals 2. So then the last one there, 4 to the 1/3, m to the 4/3. And remember, we're all just multiplying things together, so I can rearrange terms if I want, and still it's the same because of the commutative property of multiplication. So I'll take care of the 2 to the 1/3 and the 4 to the 1/3, multiply those together first. And that's, since they have the same exponent, I could write it as 2 times 4 to the 1/3 power. Okay, that's another law of exponents right there. And simplifying 8 to the 1/3, well, that happens to be the cube root of 8, which is 2. So all that boils down to just plain old 2. All right. Then if I deal with the m's, the product of all three m's there, well, hopefully you remember that one of those other rules of exponents is when you multiply terms together, you add up their exponents. Okay? So you add those together, 2/3 plus 2 plus 4/3. All of that happens just to equal, let's see, 2/3 plus 4/3 equals 6/3. Well, that's 2. All right, so that whole sum of exponents there equals 4. So my final answer there is just 2 times m to the 4th. All right, so that's about all the examples that we're going to do. Just to summarize these two laws, don't forget, folks, these are laws of exponents. There are no exceptions to the laws of exponents. They are the same every single time. But as you have no doubt seen by now, they can be interwoven with other laws of exponents, and all these different little ways of translating expressions from one form to another can be a challenge. So practice, practice, practice. All right? Learn these laws. Be confident in the fact that they are never, there are no exceptions. They are always the same. Okay? They just get combined in different ways. All right, go do some math now, folks, and be well. Bye-bye.